Everyone. My project is about predicting monitoring data using LSTM model. Let's talk about some motivations behind these final projects. Nowadays, in order to provide high availability, IaaS providers use a vast amount of monitoring and logging systems to track the state of their servers, services, and devices. The current practice of tracking the quality of service of a cluster is to set monitoring thresholds. The issue here is that if we set alert thresholds too high, we won't give enough response time to the operation team, which potentially will cause the system's downtime. On the other hand, if we set alert thresholds too low, the system will send a huge amount of alerts to operation team and cause the alert black hole. So the ideal solution would be to build up a forecasting tool which can predict the future trend of clusters' quality of service property, thus allow operation team to make actions proactively. Let's take a look at the characteristic of our data in this project. They are all time series data. Also, they have a variety of patterns across different clusters. Since quality of service is really affected by a lot of factors, they have unpredictable nature, which is challenging to some of traditional machine learning approaches. Another feature is the cluster's current quality of service always correlates with its previous quality of service status. So, is LSTM model, the long short-term memory model, perfect for our job? We know LSTM model deals with sequential input data. Not only that, but also it can learn long-term dependencies. And also, LSTM model can predict multiple timestamps into the future. Those really fit our data's characteristic. Another thing is LSTM is also able to handle multivariate input, and potentially we do want to add another features or more features into our prediction model. At the same time, LSTM, as many neural network models, it allows you to control and tune its parameters. This can be seen as LSTM's pros, and also is this model's cons, because it's kind of tricky to tune LSTM's hyperparameters, and LSTM just has so many of them. So in this project, we will focus on assessing the impact of some of LSTM's parameters, so that we can tune them to improve the model's performance. First, we built up the stacked LSTM model using the TensorFlow API. This is the structure of our model. Each LSTM layer on top will provide a sequence of output to the layer below, and the number of outputs match the number of timestamps in the input. By the end, we couple this layered LSTM architecture with a fully connected dense output layer to make a prediction. Here is the list of some hyperparameters within LSTM model, and we explored their options in our project. So we all know number of epochs is how many epochs we are going to run our model, and the number of layers is the number of LSTM layer in this stacked structure. We also set a number of neurons in each layer, and we played with the batch size, learning rate, dropout rate. We need to particularly explain this look-back window size and prediction horizon span. Look-back window size is how far we look back into our historical data and use that data to build up our sample. And the prediction horizon span is how far into the future we want to do our prediction. And this column is the configuration. And due to the time and the resource constraint, we just pick several values for each parameter in these projects. Obviously, in the future, we can set up systematic test harness to run more choices for each parameters here. And we also get corresponding model performance root mean square error to assess the impact of each parameters. Just to showcase some of our findings. This is the impact of with and without normalization. The figure on the left shows you without normalization what are the predicted values versus our actual value. We can see here actually our predicted values after a certain point it becomes constants, which just give us the bad performance. And on the right figure, after we apply normalization into our data set, we get the better predicted values which match our actual ones in the pattern. And this shows you the impact of prediction horizon span. We fix the other parameters and change the horizon as 36 hours into the future or 7 days into the future. The result shows if we predict 36 hours into the future, the performance we are getting is 0.0049, and into the 7 days future, the performance reduced to 0.018. This actually match what we expected, because the further into the future, the less power our model has. After all these experiments, we get the following optimal parameter set. We reduced our performance to 0.002, which is really good. And the visualization shows the beautiful match between the predicted value and the actual ones. So here are the conclusions after we observed the impact of each parameters we picked for this project. So we can see the root mean square error value will fluctuate with the number of epochs increasing. That's why we need to try out the different values to find the optimal epoch for particular data set. And with the number of layers increasing, we find the performance got reduced. Comparing with, we just pick a number of layers as 1, which means that based on the data we have, it's not true that adding model complexity will improve the model performance. The same thing for the number of neurons we set for each layer. We see the batch size also has the big impact on the model performance. However, not necessarily the bigger batch means the better performance. For this particular case, a smaller batch actually has the better performance. And the learning rate definitely the smaller learning rate definitely improves the model performance significantly. Also, increasing how far back we collect the historical data actually decrease the model performance in this case. And increasing prediction horizon span also decrease the performance. In this project, we investigated a couple of LSTM hyperparameters, and some conclusions are only true for this particular data set, and couldn't be generalized to cover all cases. That's why tuning neural network model is always a difficult task. However, we can conclude here, the simple model we presented in the project already yield a very good performance, and we still have a lot of room to improve on top of this simple model. LSTM is proved to be a promising tool to deal with the monitoring data prediction. Thank you, everyone. Enjoy your deep learning.